Alright guys, welcome back to a new video. So in today's video, we're going to be talking about what asynchronous encryption or RSA encryption actually is. So I'm going to show you guys what it is, like what actually is asynchronous encryption. I'm going to talk to you guys about the math behind it, why in asynchronous encryption we need our private key to decrypt our public key, right? And how that works. And then we're also going to talk about the math behind how to find our public and private keys, and the math behind encryption and decryption. So this is going to be a really cool tutorial, so let's jump right into it. So first, what is asynchronous encryption? Well, first of all, what is encryption? So you've probably heard of what we call standard encryption. So standard encryption is where, let's say, we wanted to send a message from person 1 to person 2, all right? But we don't want person 3, or let's say eavesdropper, to know what this message is. So we want to have some type of way to encode this message, right, or encrypt this message, so only P1 and P2 can understand. So first we're just going to pass some encryption key and our message into this function, which is going to send it, and P2 gets this encryption key, right? We're going to pass our decryption method using this key, right? So we're using our key, but we're using the encrypted text, our ET for encrypted text, and we can decrypt this, all using the same key. But in RSA, or asynchronous encryption, is a little bit different. How it works is we have person 1, we have person 2, but now both of these guys, they don't have a common key. They just have a public and a private key. And the way that these public and private keys are designed is that you need a public key, to decrypt a message that's encrypted with this public key. You need this private key. So let's say I have this message and I use this public key to encrypt it, right? So we can say public. So just how we had the key in our last example, this is just going to be our public key. Now we can't decrypt it just using this encrypted text and the public key. We need to decrypt it using the encrypted text and the private key. So that's the way that these keys are designed. And I'm going to show you how they're designed and why that actually works like that. So first, let's try to find a public and private key. And I'm going to show you guys how these are designed. So first, the most important part is we need just to pick two really big prime numbers. And right now I just want to do all the stuff on the whiteboard, so I'm going to show you guys a simpler way using smaller prime numbers. So we're just going to set A equal to 11 and B is equal to 13. These are two different prime numbers. And remember, these are going to be really, really large. Now what we need to do is we need to multiply both of these numbers to get what we call our n, or the product of these two numbers. All right, so we know that this is 143, and you can just do some simple math, 13 times 11, and then you can get 143. All right, so now what we want to do is we want to find all the co-prime numbers under 143. And remember, co-prime numbers is where A and B, right, so the two different numbers have a GCF of 1. So for example, let me show you what an example of co-prime number is. So 5 and 9, these are co-prime, because the GCF between these two numbers is 1, right? And this is because 5 has 1 and 5, 9 has 1, 9, 3, and then the GCF is 1, right? So that's what co-prime is, and now we can use what we call our phi function to actually figure out how many co-prime numbers are under 143. Alright, so our phi function is just going to be A minus 1 times B minus 1, and this is going to get us how many numbers under 143 that are co-prime to 143, right? So 142, 141, just like that, right? So we can just do 11 minus 1 times 13 minus 1, right? And then this is just going to get us 12 times 10, which is 120. And that is going to be our phi of n, right? Okay, so now we have A, B, n, and 5n, right? So now, using these values, we can actually get what our public key is. And with the public key, I'll show you how to get the private key. So to get our public key, it's going to be a number that is greater than 2, so 3 or above, that is less than our 5n, and that is co-prime to our 5 of n. All right, so let's plug in these values and I'll explain a little bit better. So we can plug in 120 and co-prime to 120. So what that means is it's basically going to be a prime number that is less than 120, greater than 2, and is co-prime to 120. So the greatest common factor is going to be 1. And this number is going to be 7. Alright, yeah, so that's our public key. So we can just set that up here, public equals 7. Now, we can use this to find our private. So we got to plug it into a different equation. I'll just leave this up and put it under, which is, so this is going to be for public. And to find our private, it's just going to be a public times private keys, right? And then this is going to equal to 1 mod our phi of n. So we can just plug in the values that we already have. So first we need our public key to actually find what our private key is. Now, why do we need a public key to find the private key? Well, remember that you can't just find this private key with this public key, because you wouldn't know what this 5n is. So you might know what the public key is and you can plug it in, but nobody knows what your 5n is, because this 5n, you get it from plugging those equations, but your a and your b are they're private, so nobody knows what your a and b are. So your public key, these are going to be really big numbers, so there's no way to know what your phi of n is with knowing your public key. You can't really get, that's extremely difficult. So that's why you need your public key to get your private key, but you also, to decrypt it, you can't just use your public key, because to get this private key, we use our phi of n, which we can only get with our a and b, and we only have our a and b because those only us have it. Like that's not public information. So hopefully that kind of makes sense, but hopefully when we explain it a little bit more, it'll make more sense. So we can plug this in as our public, which is going to be 7 times some number, which is going to be called x right now, is equal to 1 mod the 5n, which is going to be 120. Now what mod is it's just saying it divides 120 and you get a remainder of 1. So we can think, and basically we can come up with x as 103. Why is this? Because 103 times 7, that's going to be 121, right? So that's 2, and then 103 times 7, that's 21, that's 2, that's 1. So now we have our number. So actually, no, sorry, this is 721. Alright, so sorry for the alright, so now we have 7 times 103. So now we know our private key is 103. So you can just write that down. So now I have our public and private key, and now you realize how you can only decrypt it with or you can only get your private key with your public key, but you can't find out what their private key is because you don't know your phi, right? So that's why nobody can just get your private key, just like that. So now we can erase all of these formulas, and now I'm going to show you guys the encryption and decryption, so how that works. So let's say our P1 is trying to send a message to P2. And we already have the private keys and public keys of P2. Alright, so we already have these, and those are all up there. Alright, so now what we want to do is we want to use this let's say our message is going to be 6. So we want to send 6. All right, but this could be a verification code. Really anything relating to numbers. Right now, we could use small text. So for example, if we want to send hello, right, we could do that. But we're not going to use this for like chatting applications because we're going to be using standard encryption. The reason for that is, as I'll show you the equations, you're going to see that you need the numbers to actually encrypt this text, right? We've already only used numbers. So to convert this text into numbers, you're going to have to use the OR, right? Which is going to be, it's basically kind of just like a table that corresponds a letter to a number. And then we're just going to add up all the numbers. And if you have a 10,000 character document or text that you want to send, obviously that's an extreme example, but it's going to take a really long time to add all those up, right? If you're trying to make a real-time application. So that's why you're not going to really use this for like chatting applications, but you could use this for like verification and stuff like that. So banks actually use RSA. All right, so let's say we wanted to send the number 6. All right, so now what this is going to do is we're going to use this public key of this person. So we don't actually know the private key. So this guy doesn't know his private key. Just make sure I get the equation right. So it's going to be, to encrypt it, it's going to be the message that you want to send. So 6, or let me just write down the formula. So the message to the power of your public key. All right, so we already know this guy's public key. Is mod of n. All right, so yeah. All right, yeah, so I'm right. So it's a message to the power of the public key mod n. And remember, n is just this number. And remember, this is also private because you do it a times b. All right. So all right. So now what we want to do is no, actually no. This isn't private, but these two are private because remember these are really big numbers, so there can be a lot of different multiples to add to this. All right. But so your message times to the power of your public key is mod of n. So now we can plug this in. So our message is 6 to the power of public key, which is going to be 7, is mod n. So mod 143. All right. So we can actually pull up a calculator and we can calculate this. Right. All right, so we can do 6 to the power of 7 mod 143, and it's going to give us 85. Okay, so after calculating, we figured out that this is equal to 85. So we're just encrypting, the encrypted text that we're going to write is going to be 85. So now, if somebody wants to like try to get this code, right, to put it for themselves, maybe to cash something out, I don't know, if they use 85, well, that's going to be incorrect, right? So they don't have the way to decrypt it. So now I'm going to show you how P2 is going to decrypt it. So they're basically going to kind of do the opposite. So n is equal to, so this is the message. So this is going to be 6, right? We're hopefully going to get 6 after we calculate it. Is equal to that number, right? So the ciphered text, we're going to call this the cipher text, to the power of our decryption key. So that's going to be our private key. So c to the power of 103, let me just say private right now. So m to the power of, or equals our cipher to the power of our private, right? And that has to be mod alright, so that's just gonna be 143. So basically, this is going to be the text to the power of our public, right? This is going to be the text to the power, the cipher text, that this to the power of our private key, and both of them is mod 143. So hopefully if we calculate this, we're just going to get a value of 6 back. Alright, so now what we're going to do is we're just going to calculate the decryption function that we used on the board. So what we want to do is we want to do 85, which is our encrypted key. Remember, we did 6 to the power of 7. 6 to the power of 7 mod 143 to get this 85. And now we want to square this to 103, which is our decryption key. Last time we used our encryption key. And then we're just going to do mod 143. If you remember, that's our end value. In this, we get our final value of 6. So that means our encryption and decryption worked. Remember, we encrypted 6 to 85, and now we're decrypting our 85 to 6. So that's how our RSA encryption is going to work. Alright guys, so that's it for today's video. Hope you guys enjoyed. If you guys did, please make sure to hit the thumbs up button on the video and subscribe to the channel if you want to watch more videos like this. If you have any questions about this tutorial, you can put it in the description or the chat down below. And yeah, so that's it for today's video. Thank you guys for watching. Until next time, peace.